Welcome back, everyone. I'm absolutely thrilled to have you here for today's explainer, because we are looking at a fundamental shift in workplace software design. We're breaking down a fascinating architectural white paper on Microsoft 365 Copilot Cowork. And let me tell you right up front, this isn't just another shiny update to a chat interface, no way. We're talking about the enterprise agentic execution layer. It's a system that fundamentally redefines how autonomous work gets done in the background of your day-to-day operation.
Okay, let's dive into this. The glaring flaw in our current era of conversational AI is exactly what you might be feeling at your desk right now. The operational bottleneck remains, and the execution and application switching burden is 100% on the human worker. Sure, we have semantic text summarization and drafting, which, they're great, but the actual heavy lifting, the manual bridging between disconnected systems, the clicking, the copying, the pasting, all those mind-numbing robotic office chores we secretly dread, that is still entirely on you and me. We are the bottleneck. We issue a command, we get a text readout, and then we still have to do the actual work of applying it across our software stack.
So, to really understand this new architecture, we've got a clear roadmap for today's explainer. First, the ephemeral chat bottleneck. Second, the shift to agentic execution. Third, multi-step skills in action. Fourth, real-time human intervention. And finally, security and financial guardrails.
Let's kick things off with Section 1, the ephemeral chat bottleneck.
And this brilliantly illustrates the core of the problem. If you're a tech-curious professional, you've definitely felt the frustration of hitting a wall with basic chatbots. You ask for a complex task, and it just spits out a summary that you still have to act on. You're dealing with the limits of Generation 2 AI. It's ephemeral, it's single command, and it completely relies on manual app switching. Copilot Cowork, on the other hand, shifts us straight into Generation 4 AI. We're talking stateful agentic execution. Instead of an ephemeral little chat box, you get durable background workflows and automated orchestration across multiple apps. You define a strategic outcome, and the system coordinates the actual steps to execute it for you.
So how does that actually work? Let's move to Section 2, shifted to agentic execution. Let's lift the hood and see exactly how this paradigm orchestrates multi-app workflows on a technical level. It all starts with something called a Directed Acyclic Graph, or a DAG. When you submit a complex natural language request, Cowork doesn't just pass it to a single AI model and, hope it guesses the right answer. Instead, it uses a DAG to compile your intent into a deterministic, nonlinear execution tree. Think of it like a giant puzzle being put together. It maps out explicit parent and child task dependencies and then sequentially loads specialized skills to move from your high-level intent straight into transactional reality. But here's the thing. A multi-step tree requires different types of brain power, and that brings us to dynamic multi-model orchestration. Think of Cowork as a highly advanced traffic controller. It doesn't waste expensive computing power on simple tasks. It routes the heavy, complex reasoning, like outlining a whole multi-app plan, to frontier models like GPT 5.5 reasoning or Anthropic's Claude. Meanwhile, it quietly and instantly handles the high-volume, stateless subtasks with low-latency, low-cost utility models right behind the scenes. This is absolutely crucial because it prevents token waste while maximizing speed. To actually execute the tasks on that DAG, Cowork deploys what's called the Integrated Skill Array. These are distinct functional modules that are natively embedded right in your workspace. First, you have Enterprise Search and MCP, which stands for Model Context Protocol. This allows the system to pull real-time data from external silos and line-of-business software without needing full database replication. Then, there's the Deep Research skill for synthesizing heavily technical documents from the web or SEC filings. And finally, the Office Assembly skill, which natively builds and modifies live Word, Excel, and PowerPoint files, saving them straight to your SharePoint or OneDrive.
Let's make this concrete. Section 3, multi-step skills in action.
Theory is great, but let's look at how this execution fabric comes to life. Scenario A, building an automated client meeting packet. Your intent is simply telling Cowork to review yesterday's client discovery call and build a pitch deck. Step 1, Cowork loads the meeting skill to parse the team's transcript for customer pain points. Step 2, it triggers the enterprise search skill to find your corporate PowerPoint template and uses an MCP gateway to pull live pricing data. Step 3, the Office Assembly skills natively build a text-heavy internal Word document and brand-aligned PowerPoint slides. And finally, in Step 4, it saves those assets cleanly to OneDrive and pre-drafts a follow-up email in your Outlook. No app switching required. Literally none.
Now, what's really interesting about this slide is how Cowork handles proactive calendar optimization in Scenario B. You just ask Cowork to maximize your engineering focus time. It uses the calendar management skill to map your constraints and identify overlapping events, or meetings where you're just listed as optional. But here's the genius part. Rather than instantly executing unapproved changes and messing up your schedule, it proposes optimizations. For example, it might suggest declining an optional global design meeting to protect your focus time, giving you the final say before it sends out any automated outbound actions. In Scenario C, we see Cowork acting as a true synthesis agent for competitive modeling. Let's say you want research on a competitor's new product launch. The deep research skill runs parallel web queries, parsing press releases and analyst reports. Then, the Office Assembly skill builds a comprehensive Excel workbook with feature-by-feature side-by-side matrices, and finally, it packages all those insights into a Word value proposition document, complete with inline primary sources and footnotes. It's fully verifiable, saving you hours of manual synthesis.
So what does this all mean when things change? This leads us to a massive rhetorical question. How do you stop an autonomous AI workflow right in the middle of a task? We'll show you how Cowork handles pauses in just a second, but first, please help us hit our goal of 1,000 subscribers by hitting that subscribe button right now. It really helps us keep bringing you these deep dives.
All right, diving back in with Section 4, Real-Time Human Intervention. Because Cowork operations happen asynchronously in the cloud, those traditional, super frustrating loading spinners are just gone. Instead, you get highly descriptive, actionable telemetry in a sidebar, showing you step-by-step what the engine is processing. And if things change mid-run, you have flexible midstream interventions. You don't have to cancel the whole task and start over. You can trigger a soft pause, telling the engine to finish its active database lookup before halting so you can review the progress. If something is going terribly wrong, use a hard pause to instantly kill the active execution thread to prevent bad data from writing downstream. Or, and this is a real game changer, you can use midstream injections. You can literally drag and drop an extra file or new constraint into the active graph, and the orchestration engine recalculates only the impacted child steps, preserving all the upstream work it already finished.
Now for the vital safeguards. Section 5, Security and Financial Guardrails.
Let's be real, for any CTO or IT admin, letting an AI agent operate autonomously across business apps sounds terrifying without absolute guarantees on security and cost. So the crucial point is Cowork's zero-trust architecture. It strictly enforces a mathematical separation between the read layer and the write layer. The system is firmly bound by Entra ID and strict identity access controls. It has the clearance to read and synthesize data across your authorized environment, but it absolutely cannot commit outbound transactional changes without explicit human validation.
This is all managed through rigid human-in-the-loop governance. Before the system sends an email, posts to a shared Teams channel, or alters a CRM record, it hits a mandatory approval gate. It pauses and gives you a payload preview, a complete editable text preview of the proposed action. Furthermore, these actions are flagged with systemic risk level indicators, low, medium, high, or critical. You get a clear, explicit flag before you choose to click Approve, Cancel, or Always Allow for those safe, routine workflows.
And because multi-step agent loops definitely use more compute power than simple chat prompts, Cowork incorporates enterprise resource economics. It runs on a predictable, consumption-based credit system. IT admins can easily set granular spending limits at the tenant, department, or even the individual user level. And to prevent a background agent from getting stuck in an infinite loop and draining the company's compute budget, it has runaway interruption protections that automatically flag anomalies, pause execution, and alert the user.
Which brings us to this powerful conclusion from the architectural blueprint. The next 3 to 5 years will mark the transition from standalone applications to systemic enterprise execution fabrics. Think about that for a second. We are truly moving past the era of clicking through dozens of disconnected apps to get a single task done. By combining flexible, multi-model orchestration with real-time tracking and rigid human approval gates, this technology fundamentally redefines day-to-day work. It frees us from tedious administrative task stitching so we can finally focus on high-value strategic thinking. So how will an agentic execution layer reshape the way your team operates tomorrow? Thank you so much for learning with us, and we'll see you in the next explainer.